Have you ever watched curd form when you mix lemon juice into warm milk? That's chemistry at work, and behind it lies a type of reaction called double decomposition. Hello, young chemists. Today, we are diving into a fascinating kind of reaction where two compounds interact in solution, swap partners, and form two completely new products. This exchange of ions between reactants is the hallmark of what we call a double decomposition reaction. Picture this: compound A to B meets compound C to D, and after a bit of ionic musical chairs, we get A to D and C to B. That's A to B plus C to D gives A to D plus C to B. This isn't just theory. It's seen in the lab when you mix solutions of barium chloride and sodium sulfate. They react to form barium sulfate, a solid white precipitate, and sodium chloride that stays dissolved. You'll often hear these called metathesis reactions, and they're not limited to labs. They help us understand real chemical change in everyday life. Now, let's turn our attention to a very specific and important kind of double decomposition reaction: neutralization. Have you ever taken an antacid for a sore stomach? That relief is brought to you by neutralization. This reaction happens when an acid and a base come together to form a salt and water. The general form is acid plus base gives salt plus water. At the microscopic level, the hydrogen ion from the acid joins forces with the hydroxide ion from the base, and voila, you get water. For example, hydrochloric acid HCl reacting with sodium hydroxide NaOH forms sodium chloride NaCl and water. That's HCl plus NaOH gives NaCl and H2O. Neutralization plays a huge role in everyday scenarios, from balancing soil pH in agriculture to treating industrial waste, and even in making soap. So, why exactly is neutralization considered a double decomposition reaction? Well, let's look at what really happens. When HCl reacts with NaOH, the hydrogen ion from the acid and the hydroxide ion from the base combine to form water. Meanwhile, the sodium ion from NaOH and the chloride ion from HCl form the salt, sodium chloride. So it's clearly a reaction where both partners, the cations and the anions, have switched. In other words, both compounds decompose and recombine exactly as they would in any double decomposition reaction. If you look at the solution at the ionic level, you'll see all these ions floating around, recombining into completely new compounds. This visual of ions moving and forming new bonds is what defines the essence of these reactions. So yes, every neutralization is a double decomposition. But not every double decomposition is neutralization. Let's spice things up a bit and explore the different types of neutralization. These aren't just dry reactions, they determine whether the resulting salt is acidic, basic, or neutral. When a strong acid meets a strong base like nitric acid, HNO3, and potassium hydroxide, KOH, they fully neutralize each other and give a neutral salt, potassium nitrate, KNO3, and water. That's HNO3 plus KOH gives KNO3 plus H2O. But when a strong acid reacts with a weak base, say hydrochloric acid and ammonium hydroxide, the result is an acidic salt, ammonium chloride, NH4Cl. Flip the situation, a weak acid like acetic acid, CH3COOH, reacting with a strong base like NaOH, forms a basic salt, sodium acetate. Understanding this helps us predict the behavior of salts in solution, whether they turn litmus paper red or blue, or affect pH in biological systems. These variations help us explain how the chemistry of salt formation is far more than just water and flavor. Now let's walk out of the lab, because neutralization is happening all around you. Got a stomach ache from too much spicy food? Magnesium hydroxide in your antacid neutralizes the excess hydrochloric acid in your stomach, That's a neutralization reaction in action. Farmers add quicklime, calcium oxide, to acidic soil to make it more fertile by increasing its pH. In factories, acidic waste from chemical processes is neutralized with bases before being released into rivers, a crucial environmental safeguard. Ever wondered why toothpaste tastes a bit chalky? That's because it's basic and designed to neutralize acids produced by bacteria in your mouth. Even soap is made using this principle, alkalis reacting with fatty acids to form salts that clean. So, neutralization is not just textbook chemistry, it's a part of your health, your food, your environment, your world. Let's bring this alive with a classic lab experiment. When you mix dilute sulfuric acid with sodium hydroxide, the indicator phenolphthalein turns from pink to colorless as the solution reaches neutrality. It's a clear signal that neutralization has occurred. And if you're watching this in the lab, you'll notice a temperature rise. That's because neutralization is exothermic. You release heat as new bonds form between hydrogen and hydroxide ions. If you see the titration setup in front of you, look closely at the burettes filled with acid and base, the conical flask, and the indicator. It's a beautiful orchestration of ions and color that shows chemistry in motion. This isn't just about mixing things, it's about watching transformation, energy flow, and precision measurement all in one reaction. Let's quickly revise what we've learned about double decomposition and neutralization reactions. A double decomposition reaction occurs when two compounds exchange ions to form two new products. Neutralization is a special case where an acid reacts with a base to form salt and water. From relieving stomach acidity to treating wastewater and fertilizing crops, neutralization plays a silent but vital role in our lives. We saw the classification based on strength of acids and bases, real life examples, and even visual experiments that prove this theory works. I hope now you understand how this concept is far more than a line in your syllabus. It's the chemistry behind comfort, cleanliness, and cultivation. Catch you in the next class where we'll explore more reactions that shape the world around us. Until then, stay curious and stay chemically connected.